Talking about nth root and rational exponents, and we are solving using common bases. And the way that common bases work is exactly the way it sounds. If you have a common base, so in this case, if b raised to the a power is equal to b raised to the c power, then a and c have to be equal. And so what we want to do is we want to find equivalent ways to write each base. So in this case, if we're looking at 64 to the a power, and what would that have to be in order to equal 4? So we know that we can write 64 as a power, as 4 raised to some power. So 4 raised to the third power, that is equal to 64 if you put it in your calculator. And we still have the a left over from the exponent. And so now we have a base of 4. Over here, we do have a base of 4, but remember we have an understood 1 as our exponent. So we can use our power rules and we can distribute our a into the parentheses there. So we get 3a equals 4 raised to the 1. And now at this point, we know that if it's common bases, then the exponents have to be equal. So we don't need the 4's anymore. And now we can say 3a is equal to 1, divide by 3, and then we get a is equal to 1/3. Next example here, we have 32 and 4. We can't write 32 in terms of 4, but what we can do is we can rewrite both bases so that they're the same. So 32, we can write that as 2 to the 5th power. And 4, we can write that as 2 squared. When we distribute, we get 2, 5a is equal to 2 squared. And now we can get rid of our 2's. We don't need those anymore because we have common bases. So we have 5a is equal to 2. Divide by 5. And then we have a is equal to 2/5. We have one more example. We know that we can rewrite 9 in terms of 3, and we can write 27 in terms of 3. So 3 squared, and then we still have to have that multiplied by a, and then we can write 27 as 3 to the 3rd. So we do our multiplication, power multiplication. 3 raised to the 2a is equal to 3 to the 3rd. Our bases cancel, and we get 2a is equal to 3. Divide by 2, and a is equal to 3/2.